Okay, so adding in convection. So with the metal rod and the heat flow, it's not quite as obvious, how this may work. But you could think of it as a hot blast or something. All of a sudden, that typically, we have our two ends. Here's a T1 and here's a T2. And maybe the heat is, let's say it's flowing this way. As far as the diffusion, actually could be flowing both directions in terms of the diffusion. It could be flowing in, depending on what the initial state was, it could be coming in from both ends. But it may also just be going the one direction. And so let's think of it that way. Now, if all of a sudden I give just really quick at some point, I give a hot blast, hot blast that just for a moment sends this up to some T3 that's even bigger than T1. Well, but then take it right back down and back to T1. Well, what you'd probably expect to see in here over time is, sort of that blast, here's the little heat wave, this is extra high. But as it travels through, it will also probably diffuse and sort of here, maybe it was a really tight thing, but then it starts spreading out, and that heat, it's still a kind of a pulse, but it starts spreading out. And if the rod is long enough, by the time you get to the end, you won't even notice it. They use in the textbook the example of adding pollution to a stream. So you add pollution to the stream, and you would see, if it comes in sort of as a big, big instantaneous thing, then, you would tend to see that big blob like an oil slick or something going down the stream. But over time, it would spread out as well because of the diffusion process. So, how do we model this? And in this case, it's the convection we tend to model as is proportional to u sub x, or the space derivative. Okay, so it's going to move faster along here if the heat is moving faster along there, as far as a fast stream, right? It's going to send that pollution down very quickly, whereas a slow stream, you'll tend to see that pollution sit in one place and spread out more from there. So the bigger the convection, actually more likely you'll see, kind of that big, say, oil slick moving down the stream, whereas the bigger the diffusion, you would tend to, see the oil slick when it first has appeared, but it will spread out very quickly, and you might not notice it as a big blob very quickly. And so, again, going back to sort of the original diffusion, we have alpha squared u sub x, and then minus v u sub x. And now in this case, again, of course, the constant in this case could be positive or negative. Let's see. Yeah, and as I said, it's going to again, relative size will kind of dictate what we actually see. You know, do we see something spreading out very quickly within the stream, or do we see it kind of hanging together much more and moving down the stream more quickly? Either one could be the case. And so this is our what we call our diffusion convection equation. Okay, and so that will do it for convection, or diffusion convection.